Hey guys, so this video is about arc length and sector area. So the previous piece was about circumference and area of circles. Now we're only going to be talking about a portion of it. That portion is called arc length and sector area. So by the end of this video, we're going to review both of those. So first thing, arc length. Arc length is a portion or a piece of the circumference, okay? So it's just the piece that's around the outside of the figure, but we don't know all of it. We want only a little bit of it, okay? So to find this, we do L, cursive L, and it's found by taking the angle in the middle. We call this the central angle. Dividing by 360, the distance around the angle around the whole circle, right? If I'm doing a 360, I turn around in a circle. And then I just multiply by my circumference formula. I write it out as angle over 360 times 2 pi r. So the abbreviations for this also, you'll notice AB, meaning from A to B around this kind of curve piece. That means arc length. Okay, so whenever you read that, it's A to B arc length. So if I'm doing this example, you'll see that the angle is 135. And then I'm going to divide that by 360. And then I'm going to multiply by 2 pi. And then my radius is 8 in this case. So the first thing I'm going to do is I'm going to do 135 divided by 360. And that's going to come out as a decimal 375. Or 0.375. Then I'm just going to multiply by that 2 pi and then 8. And I can just keep that all into my calculator. If you want to just plug it right into the calculator right away, you just have to make sure you have parentheses around that. And you should come up with the arc length AB, that curve there, that portion, is 18.84 inches. Now, I used the pi button on my calculator. You can use 3.14, and your decimals are going to be slightly different than mine. So that's how you find arc length. It's just an application of circumference. So let's take a look at some more problems. Okay. Now we have this circle over here, and again we're finding the length of each arc. Okay, so we're going to use that angle over 360 times 2 pi r. So in this case we want D to E, this section right here. So the first bit of it is finding the angle. The angle in this case is 120 over 360 times my 2 pi, and now it's telling me my radius is 2 meters, so times 2. If I do this division, again I'll put that in parentheses. Again, if you're going to do that on a calculator in one step, you have to put it in parentheses. You're going to get 0.33 bar times 2 times pi times 2. Grand total for this is 4.2 meters. When I multiply that out, that means that this purple section right here is 4.2 meters in length. The trick question comes from number 2, where it says DEA. Now, you'll notice that it doesn't have 2 letters, it has 3. It means I'm going to start at D. I'm going to go through E onto A. It's what we call a major arc, or an arc that goes past 180 degrees, or half the circle. Well, what is the angle in there? Well, I know this angle is 120. And I know this is 90. So I'm going to do 120 plus 90, and I get 210. So to solve for 2, I'm going to use that 210 divided by 360 times 2 times pi. Now you notice it gives me my diameter. My diameter being 3.5. So I'm going to do that division. 210 divided by 360, and I'm going to get 0.583 times 2 times pi times 3.5. And when I multiply that, I get 12.8 inches. So that's the length, that's that orange length. Now, I'm going to erase some of this, or I'm going to do number 3 down here. So, in this case, it's asking me how long is BC. BC is this. So I know my angle. My angle is 45 over 360 times 2 times pi times my r. So now, in this case, it tells me BE is 24 feet. So B to E is 24 feet. Which means that half of that, B to O, is 12. So that's 12. Again, I'm going to do that division. I'm going to come up with 0.125 times 2 times pi times 12. My grand total for this should come out to be 9.4 feet when I plug it into my calculator. Second piece, or the fourth problem, deals with CBA. CBA. So again, it's that 3 letters. So I'm going to start at C, I'm going to go to B, and then I'm going to go to A. CBA. So I have to find that angle. Well, if this is 90, this is 90, right? So I'm going to do 45 plus 90, and I get a grand total of 135. So for question number 4, I'm going to do 135 over 360 times 2 times pi. Now I need my radius. Well, the information that they give me is that D to O is 3 millimeters. Now the radius goes from the center to the outside of the circle, which DO it does. So that is my radius. Now I'm going to do that division again, and I'm going to get 0.375 times 2 times pi times 3. My grand total for number 4 comes out to be 7.1 millimeters. Now, that is arc length. So remember, it's angle over 360 times 2 pi r, and the symbol for it is the 2 letters with the arc over it. Now we go down to areas of sectors. Sectors are like pie-shaped portions, okay? Like pieces of pie. And they use the same principle, okay? It's not the whole circle, it's a little bit of it, okay? So, I use the formula, okay? The area of a sector equals my angle over 360 times my area of my circle, pi r squared. That angle being that portion of that 360 that I'm dealing with. So that's the formula I'm going to use to find the area. So angle over 360 times pi r squared. In this case, my angle here is 90 over 360 times pi times my radius, which is 2 squared. Now I have to remember, I'm going to do this division still. I'm going to do 0.25 times pi. Now I have to square the 2. 2 squared is 4. Now I can multiply everything out. I should get 3.14 inches squared. Because now I'm dealing with area. So my units are squared. Some other examples of this. Okay? Find the area of the sector if the circle has a radius of 10 and a central angle that measures 72. So again, I'm going to do the 72, because that's my angle, over 360 times pi times 10 squared. I I do that division. 72 over 360 is 0.2 times pi times 10 squared is 100. My grand total for this should come out to be 62.8 cms squared. Okay, centimeters squared. Number 2 says find the area of the sector if the circle has a radius of 5 inches and a central angle of 60. So again, angle over 360 times pi times 6 squared. I do the division. I come up with 1.67 times pi times 36. So you have to make sure, why am I saying 6? This is 5. This is 25. So we gotta make sure that I'm squaring this, okay? And now when I do that multiplication, I should get 13.1 inches squared. 3 is a tricky one because now if the area of a sector is 15 pi, meaning if the area, this area, is 15 pi, okay? Now, and the radius of the circle is 5, now I have to find the angle. So if I'm writing this out, area equals angle over 360 times pi r squared. When I plug this stuff in, my area is 15 pi times, I don't know my angle, or equals, I don't know my angle, that's going to be my x over 360 times pi times my radius squared. So, the first thing I'm going to do, and have to notice on this, you notice that pi's are on both sides? So, when they're on both sides of the equation, and I'm solving, they actually cancel out when it's all multiplication. They cancel out. It's like dividing both sides by pi, they just cancel out to 1. So I can make this a little bit easier. So we get 15 equals x over 360 times, well, 5 squared is 25. Now, a lot of you are looking at this and going, I don't know how to work this. Well, remember this 25 over 1. So, I can write this as 15 equals 25x over 360. Because I just multiply straight across. Now, I just have a proportion. Because it's across an equal sign. So I cross multiply. I get 25x equals 5,400. And then when I divide by 25, my angle, my x, equals 216. So that's how you solve for that angle if I'm given it. Please complete the practice problems and come in with any questions that you have for me. Thank you.